Welcome to lesson 1 in module 2. Today we're going to talk about knowing and applying the properties of integer exponents to generate equivalent numerical expressions. So we're pretty good when it comes to exponents like 3 squared, meaning 3 times 3, and that gives us 9. But we're going to look at what happens when we have like 3 to the negative 1, or if we have 3 to the third, So we're going to look at all kinds of different situations here. All right, so if you take a look at this table, it shows us all the different exponents, starting with to the fourth, third, second, first, and then to the 0. Well, if you look at what's happening each time you end up dividing by 5. So if you look at the top one, to go from 625 to 125, you divide by 5. And again, divide by 5, and then divide by 5. So here we're at 5 to the first, which we know is 5. Well, let's follow that pattern. If you go down again, we should have to divide by 5. Well, 5 divided by 5 is 1. So 5 to the 0 power is going to be 1. Then if we go down and we go from 5 to the 0 power, so if we take 1 and divide it by 5, we get 1/5. Okay, and then again, let's divide by 5. So 1/5 divided by 5. We know that that means 1/5 times 5 over 1. Or I'm sorry, still be divided by 5 over 1, which means 1/5 times 1 over 5, because we have to multiply by the reciprocal, and we get 1/25. All right, so let's take a look. When you look at the patterns, you notice that for the pattern, when it's going down, you're dividing by 5. So as the exponent goes down, the value decreases by, and we can say decreases by 5 times or by dividing by 5. And so as the exponent goes down, the value decreases by dividing the power by 5 each time. Okay, let's take a look at the 4s. Does that work? Even if we're not sure for 256, we can take a look. 64 divided by 4 is 16. Divided by 4 is 4. So let's take a look and think logically. Well, 4 divided by 4 is going to give us 1. 1 divided by 4 is going to give us 1/4. 1/4 divided by 4 is going to give us 1/16. Right? And then here, if we just follow the pattern, we know 3 to the 0 power should be 3. Should be 1. And then 3 to the negative 1 should be 1/3. And then 3 to the negative 2 should be 1/9. Because all of them follow that same pattern. As the exponent goes down, it decreases, but it decreases by dividing the power by the base. So this time with the 4s, it decreases by 4. And then with the 3s, it decreases by dividing by 3 each time. All right. So for D, E, and F, it asked us to follow through on the patterns, which we already did. So again, you just have to remember, as your exponent goes up, you multiply by the base. As your exponent goes down, you divide by the base. Okay, so write a general rule for the value of a to the 0 power. Well, anytime that we had, so when we had 5 to the 0 power, it was 1. 4 to the 0 power was 1. 3 to the 0 power was 1. If you think about it, any number to the first power is going to be itself, And when you divide a number by itself, you're going to get 1. So all numbers that are to the 0 power, so for any number a to the 0 power, the answer is 1. Okay, and let's take a look. Write a general rule for the value of a to the negative n. So this one goes here. Let's go back to those rules. And actually, I'm going to pull it over here. So here, when I had 5 to the negative 1, it was 1/5. When I had 5 to the negative 2, it was 1/25. Well, notice, isn't 5 to the first power? And isn't 25 5 to the second power? So anytime you have a power that's to the negative, so when you have a, so any number a to the negative n, it's always going to be 1 over that number to the positive power. So again, let's take a look. When we had 4 to the negative 1, did it equal 1 over 4 to the first? Well, when we look back at our answer here, 4 to the first would be 4, and that's what we had. And then you can double check. So for 4 to the negative 2, we had 1, and it should be 4 to the second. Let's take a look. 4 to the second, was it 1/16? Absolutely. So this rule works. Okay, so here's your rule for a to the negative n, and then your rule for a to the 0. The next thing we're going to talk about is exploring the different properties of integer exponents. So let's take a look back at what exponents mean. So when I have repeated multiplication, I know I can take that number that I'm multiplying, so I'm multiplying 3, and I'm doing it 5 times. So 3 becomes my base, and 5 is my exponent because that's how many times I'm multiplying it by itself. Well, let's take a look at this next problem. We have 1, 2, 3, 4 3's inside parentheses, and I know I do the parentheses first. So I could shorten that to 3 to the 4th power. Okay, and then I have times 3 to the 1st power. So this is 3 to the 4th times 3 to the 1st. So when I do that, so 3 to the 4th times 3 to the 1st, because I'm multiplying them all together, I can get 3 to the 5th. Okay, because isn't this with multiplication, does it matter what's going first and what's second? No, multiplication can be done in any order. So here, if we look, we have 3 to the 3rd and 3 to the 2nd. Again, I'm still multiplying it 5 times. 1, 2, 3, 4, 5. So it's still, oops, that should be a 2, 3 to the 2nd. So it's still ending up being 3 to the 5th power. So all of these are 3 to the 5th power, but they're all written in different ways. So what pattern do you see when you're multiplying 2 powers with the same base? You should notice that you add the exponents. Okay, so I took my exponents and I added them to get my new number. Okay, so then now I have, so let's test this. I have 5 squared times 5 to the 5th. If you extend this out, 5 squared means 5 times 5. So that would be 5 times 5 times 5 to the 5th, which if you extend this out, would be 5 times 5 times 5 times 5 times 5. So I have 1, 2, 3, 4, 5, 6, 7. So this would be 5 to the 7th. And when I take these and I do 2 plus 5, so 2 plus 5, I get 7. With division, so I have 4 to the 5th divided by 4 to the 3rd. Well, we know that when we're dividing things, whatever we do, so if I have the same thing on top as I do on bottom, I can cancel the things out. So here, if I have 4 to the 5th times, or divided by 4 to the 3rd, I know that these 4's can all cancel each other out. By doing that, I'm left with 4 times 4, which I know is 4 to the second. Well, look at your exponents. You had 5 to the third, or I'm sorry, 4 to the fifth, and 4 to the third. So if I take 5 minus 3, it gives me 2. So the pattern here is that you are subtracting the exponents to get the new exponent. So if we follow that pattern, I have 6 to the 8th and 6 to the 3rd. If I follow that pattern of subtraction, I should get 6 to the 5th. Okay, now C is a little bit more complicated. Right, so you have 5 to the 3rd squared. So 5 to the 3rd means that I'm doing, and I'm actually going to say go ahead and cross this part out.
Denarius
Okay.
and Mazai. Denarius
So
and Mazai,
5.
report to the cafeteria, please. Denarius, Mazai, report to the cafeteria, please. Immediately, please.
So 5 to the 3rd squared means that I'm doing 5 to the 3rd times 5 to the 3rd. Okay, so give myself some more space here. This is, actually, I don't want to do that. So I have 5 to the 3rd times 5 to the 3rd. That's what 5 to the 3rd squared means. So then now that means if I break it down more, I'm doing 5 times 5 times 5 times 5 times 5 times 5. And when I do that, it ends up being 5 to the 6th. Well, what do you notice about these two exponents and your answer? Since I ended up with 5 to the 6th, I've noticed that the result is the exponent. So if I multiply the exponents, I get the new exponent. So then if I follow that rule, here I have 7 squared to the 4th power, so I should end up getting 7 to the 8th. Right. So let's take a look and let's make these rules. I'm going to use orange for this one. I'm going to use purple pen for this one. And then I am going to use yellow pen for this one. Alright, so starting off, I noticed that when I multiplied my exponents, so for any problem, a to the m times a to the n, as long as my bases are the same, it becomes a to the m plus n. My rule for dividing. So if I have a to the m divided by, whoops, that wasn't correct. That's not where the division sign goes. There you go, divided by a to the n. My solution should be a to the m minus n. And then for power to a power, if I have a to the m to the n, the result will be a to the m times n. All right? So when you're working through problems and simplifying them, you still have to go through your order of operations. So here you'll notice that what we did first was we had to do the 5 minus 2, because that was inside parentheses. And then I could also do the 5 plus 2, because that was inside parentheses. The next step is to do my exponents. However, instead of extending those exponents out, we can use our rule. So in this case, I'm multiplying two numbers. So go back and look at the multiplication rule. The multiplication rule tells me that I can add my two exponents. So that's what I'm going to do. Since 3 and 3 are the same, I can take 5 and add negative 8 and turn this into, instead of 3 to the 5th times 3 to the negative 8th, I can just change it to 3 to the negative 3rd. I also know that for the rule of 0, that any power or any number to the power of 0 gives me 1. Then I can use my rule for negatives, and I know that it'll be 1 over 3 to the 3rd, which is how I get the 1/27 plus 1. So I get my answer of 1 and 1/27. Okay. So you have examples here. I'm not going to go over that same one again, but we're going to do 2 problems. I would like you to do this one with me and then this one on your own and come back and check. All right, so first I have 6 minus 1 squared to the 2nd power over 3 plus 2 to the 3rd power. All right, so my next step, I'm going to do my different steps in colors. My first step will be to do the parentheses. So I will get 5 and 5 because I'm doing 3 plus 2 and 6 minus 1 because those are in parentheses. And then I end up with this being to the 2nd power and all of that being squared as well. Then I have 5 to the 3rd power. Give the board a second to catch up to me here. There we go. Okay, and then so now I have 5 to the 3rd power. There we go. So now let's do the work up here. So 5 squared is going to be 5 to the 2nd power, and then I'm taking that to the 2nd power, still over 5 cubed because there's nothing else to do. My next step would be to, since I have power times or power to a power, I can multiply these two and I get 5 to the 4th over 5 to the 3rd. Since I'm dividing, now I can subtract 4 and 3, and I get 5 to the 1st power, which I know is 5. Okay, I want you to go ahead and try this problem on your own, and when you come back, we'll check your work. Okay, so here we got 5. Here, our first step will be to do the parentheses, so I have 2 squared to the 3rd power minus, this would end up being 4 to the 3rd power times 4 to the negative 5th power. All right, so now here I have a power to a power, so I multiply and I get 2 to the 6th minus 4 to the 3rd times 4 to the negative 5th. Here I'm multiplying. Since I'm multiplying, I can add my exponents. So I do 3 plus negative 5. So I have 2 to the 6th minus 4 to the negative 2nd. So 2 to the 6th power, remember, is 2 times 2 times 2 times 2 times 2 times 2. Well, I know 2 to the 5th is 32, so I know this is 64. Minus, well, I know that anything that is to the negative power is 1 over the positive power, so I have 1 over 4 squared. So this is going to be minus 1 over 16. When I do that, I would get 63 and 15 sixteenths. You have the problems in your guided practice. This is going to be a little bit difficult because you're writing things to a power inside of Google Forms when you do that. So like if you're doing 6 squared, you would do 6, and then this caret, and then 2. So this is how you show that there is an exponent when it comes to Google Forms. As always, if you have any questions, please be sure to write them down or email me so we can go over them in class.